Hello, this is Dr. Liu. In this video, we'll go through right angle triangles and the Pythagorean theorem. So let's talk about triangles in general. So we have here, let's not make it equilateral. So we have a triangle. So the triangle has three sides, A, B, and C, and also it has these three separate angles. Typically we just use theta 1, theta 2, theta 3, and this theta is a Greek letter. Okay, so we have basically three angles and three lengths. So okay, it's three lengths. Let's just spell it as L-E-N, and we also have three angles. Well, not all of them are independent from one another, though. If you think about it, if you were to say to increase the length of B, say making it stretch a little further, well, the angles are going to change. Even if the lengths A and C are not changing, the angles will be changing. So you cannot really independently change just one thing without changing some other things. So they're all related, in any triangle, there are only three independent parameters. So three of these, six are independent. Okay, this further gets simplified when we're only dealing with right angle triangles. So now we have a right angle. So basically there's only two independent things that we can choose, because one of the things has been chosen as an angle and it is 90 degrees. So we only have two independent things that we can choose. Alright, so let's do one of the variations, two independent things. Let's choose two lengths. Okay, so we have two lengths, and that means we can determine the third length and also the other two angles, given that one of the three angles is already a right angle. So let's take a look at what this question would look like. So we have two lengths, a right angle, third length. So we have AB, and here we have an angle theta 1 and an angle theta 2. And this is our C. Okay, so I want to claim that with two lengths known, AB or AC or BC, I can find the other lengths and also the other angles. So with two lengths, and find one length and two angles, because the third one is the right angle. Okay, so how do I execute this? Given two lengths, and find the other lengths and the other two angles. We'll just do this step first, given two lengths and get the third length. So let's just say that given A and B, find C. Okay, so according to Pythagorean theorem, here's how to find C. So Pythagorean theorem says the C, which is this diagonal thing, we call it hypotenuse. And if we're using theta 1 as the angle we're interested in, this A here is adjacent to the angle, so A is adjacent. The B opposes the angle, so B is opposite. But if we're choosing theta 2, then A becomes the opposite, B becomes the adjacent. So anyway, the adjacent and the opposite, each squared will be summing to the hypotenuse squared, or hypotenuse squared. So that is Pythagorean theorem. So if you have A and B, so then C will be equal to A and B squared, right? Square is that. And then if you take a square root on both sides of the equal sign, this is how you would determine C. So what if you have, say, given A and C, find B? Okay, so we still use the same equation, except that we can, say, subtract a squared on both sides, so that the left side becomes this. So if you subtract a squared is gone. And subtract a squared on the other side, a squared becomes negative, right? So now we can get, if we square root both sides of the cosine, so that's how we can find B if we're given A and C. And the same type of question, if we have B and C, right, there's only one other variation, is this. Let's find A. So the same thing we can do. We can subtract the B squared on both sides, and we'll get A squared is equal to C squared minus B squared. And then we take the square root on both sides of the cosine A is equal to C squared minus B squared square root. So this is basically how to use Pythagorean theorem to find the missing lengths, given two lengths, to find the third length. And we haven't talked about these angles. There's also two angles that we should be able to find given these two lengths, right? So we'll do a little preview here. So we still have this same right angle triangle, and we want to know angle theta 1 and theta 2, right? And we're given two lengths, well, whichever combination, AB or AC or BC. So just for simplicity, let's say that we know AB. So I actually want to say this tangent, which is a trigonometric function of theta 1. So that's this thing here, is opposite over adjacent. So this is opposite over adjacent. So that is when you're concerned with theta 1, and this side is adjacent to theta 1, this side is opposite to theta 1. So this is B over A. So using this, you can actually find the angle theta 1. The way to do it is to ask this question: what angle's tangent is equal to the fraction B or A? Since you know A and B, you can find the fraction between them, right? So the answer to what angle, when taking the tangent, gets this, is the inverse tangent. So we sometimes write tangent minus 1. And we'll just put, this is the fraction that the two sides make, and this is going to be the angle they must be making, right? So another way to write it is to say A tangent B or A, or arc tangent B or A. So these are all equivalent expressions, and they appear in different texts as different methods of writing them. The minus 1 by no means gives you some sort of invert, such as A over B instead of B over A. This minus 1 is actually the invert function. So basically what angle? Find this angle that makes these two sides a certain fraction, right? So that is how you can find the angle given two sides. And the other side, you can do the same thing. Tangent theta 2 is opposite of theta 2 over adjacent of theta 2. So let's shop for opposite side. So here's our theta 2. And opposite side is not this one anymore. That's adjacent. This one actually is a hypotenuse, right? So this is that opposite now. So it's A. And the adjacent is B. So it's A over B. And you get the theta 1 is tangent minus 1 A over B. So if you are given two lengths, you can find the third length and the other two angles that are unknown to you, right? So that is one example of given A and B. So I'll do one more example of given, say, A and C. So if you know A and C, so this is actually A and B are both known, right? So what about A and C are both known? Well, this is the adjacent, right, to that angle. Adjacent, this is hypotenuse. So I can define another trigonometric function, which is cosine theta 1 is the adjacent over hypotenuse. Well, the hypotenuse is always the same length, the longest line here, so there's no need to have double quotes here because the C is the only one that is the hypotenuse. And A and B, they can switch their roles, which one's opposite, which one's adjacent, depending on which angle you're concerned with, right? So in this angle's adjacent is A. So this is actually A over C, right? So if you know A and C, for example, then the angle can be calculated back by an inverse cosine of A over C. Alright, so if you actually know B and C, for example, then the theta 2 here can also be calculated as cosine, but we can also calculate theta 1 here as there's an opposite over there's a hypotenuse. So a third function we'll define is sine theta 1 is the opposite of theta 1 over the hypotenuse. So the opposite is B, opposing the angle, and that's hypotenuse, is B over C. So now this angle theta can be calculated as the inverse sine function of B over C. Alright, so you could try and calculate the other angle also using inverse functions, but you probably already know that these angles add to 90 degrees, so you don't really have to. You just calculate one of the two angles and get the other angle with 90 degrees minus the first angle, or get whichever one you got first, and you can use 90 degrees to subtract that first angle you got. Right. So this is just a quick review of what exactly can you do with a right angle triangle. Well, if you know two lengths, this is how you find the third length using Pythagorean theorem. How do you find the angles? Well, depending on which lengths you are given, you can use these tangent functions and inverse tangent. Then you can use cosine or sine functions depending on what was given. But what you can always do is, even if you're not given A and B, say if you're given A and C, you can find B and still use tangent if you prefer that way. That works too. Same thing over here. If you're given B and C, and then you found A, and then now you have A and B, and you can go ahead and use A and B and arctangent to find the angle. Thanks.